For today's class, please go through the video, try to find the error if any, and try to complete the task given by the question and also the table in the question. Let's have a look at the question. Mr. Tan is a housewife who visits several locations every day. The diagram shows the displacement vector, vector B, vector C, vector E, and vector M that represent the journey of Madam Tan from her house in A to the locations she normally visits. So let's have a look at the diagram. As you can see from this diagram, A is Madam Tan's house, and B is market, C is mother's house, and D is a school, M is a kindergarten, and the X is grocery store. So let's try to solve the question based on the diagram. Now you need to write the vector B, C, E, and M in the form of the xy and xi plus yi, which is unit vector, and if the side is equal to 1 kilometer. Right, so this is A to B is represented by vector B. That means Madam Tan go to the market is represented by vector B. And then for the M is actually represented by vector M. Right, that is the vector for Madam Tan to travel from her house to kindergarten. And at the same time, if Madam Tan go directly to visit her mother at the C is her mother's house, then this is 2 times of the vector M. And then for the point D is the school. Point D is the school, and if Madam Tan directly go to the school, sending her daughter to the school, is representing by vector C. So we observe that there is another vector. Okay, there is another location which is X, is a grocery store. There is no vector for that line, but we have the vector E, which is actually from the school to the kindergarten, right? Now, the task is you must write the vector B, C, E, and M in the form of the vector column xy and also unit vector xi plus yj. One side of the box represents 1 kilometer. So now we are going to write all the vector in vector column and unit vector. So let's start with vector B. For you to write the vector in terms of the vector column or unit vector, you need to draw the triangle like this. You need to apply triangle law. So instead of go directly A to the point B, go to the market, Madam Tan can travel 3 units to the left and then go down, right, 8 units. So it's -8. So the vector column is -3, -8 for Madam Tan to go to the market. And you also need to write the vector for the vector AB in terms of the I and j. So you can write as -3i minus 8j. For Madam Tan to go to the kindergarten, that's vector M. So if I'm going to draw using the blue color pen, the triangle that I can form, it seems like is how many I? I am having, okay, I need to draw the vertical line and the horizontal line. So it seems like it's 1, 2, 3 and a half, 3.5i, and then go down 4, right, minus 4j. So if you want to write in terms of C, how many C is actually counting the box 1, 2, 3, 3.5. 10 box is C. So we have 3.5. That means one box is 0.1 C. So you can write as 0.35 C. But I'm going to write in vector column and also unit vector. So I don't have to write in terms of how many C, right? Okay, so let's count the grid. We have 3.5. So this is 0.35 C actually. But we don't want to label like this. We want to know how many I and how many j. So if I'm going to write AM, I will write as 3.5 and minus 4, right? Because it's going down 4. So always draw the right angle triangle so that you can study the horizontal component and the vertical component, because the vector always got two components. So this is going down is -4j, and to the right is positive 3.58i. So the vector AM we can write as 3.5i minus 4j, or we can write as 3.5 and -4 for vector M, right? You can write as -3.5i minus 4j is okay. So we have two ways of representation of the vector. Now for the next one, we have to express all the vector in terms of I and j. Now for vector, okay, for vector E, we can draw, we always figure out along the x-axis. It seems like D to M is moving to the 6 unit to the left, so it's -6i, and moving down 4, so it's -6 minus 4, right? That's vector DM. You can write -6i minus 4j. This is called unit vector. Now for one more is from A to D. This is vector C. So vector C we can write as 10, 0, or we can say as just 10i, no j, 0j, so we don't have to write j. So vector C is 10i, or you can write as vector column 10, 0. Now we have solved writing the vector in terms of x, y, and xi plus yj. For next question is, after that, find the shortest distance from Madam Tan's house to every location. According to the given displacement vector. So now we need to find the shortest distance. So for Madam Tan to travel to her daughter's school is magnitude is 10 kilometer, because one unit represent 1 kilometer. We have 10 boxes, so it's 10 kilometer. And from Madam Tan's house to the kindergarten, it was given vector m. So this distance is actually the shortest distance. So we want to calculate the distance. We need to draw the right angle triangle so that we can use a Pythagoras theorem. So there are two paths that Madam Tan can go to the M, which is her son's kindergarten. So you must use a 4 square plus 3 square, which is actually 5 kilometer. So it's considered shortest from A to M, rather than she traveled 4 kilometer downward and then turn to the right 3 kilometer, which take about 7 kilometer, which is further. So if Madam Tan want to go to the market, so the shortest distance, if we use a Pythagoras theorem, we will get from A to B is using the 3 square plus 8 square. So 3 square plus 8 square, we will get the answer for the shortest distance. So you can write the answer is 73. That is so-called shortest distance. So we always write the distance as a magnitude of the vector, which is equivalent to 73. So let's move on to another location. Now if let's say Madam Tan sent her son to kindergarten, it takes 5 kilometers. And because the vector from kindergarten to the mother's house is also 5 kilometers, so the total distance for Madam Tan to go to her mother's house is 10 kilometers. That is actually the shortest distance. And if Madam Tan go to the store, grocery store, we need to read the distance by drawing out the right angle triangle, and we have to count the box is 8.5, and then going down is 4. So the total distance is 8.5 square plus the 4 square. Then we will square root the answer, square root of 88.25. So the answer is about 9.39 kilometers from A to grocery, right? 9.3941 kilometers. Alright, so we have discussed about the magnitude and the shortest distance from Madam Tan's house to every location according to the displacement vector. Now, Madam Tan will send her son to the kindergarten before sending her daughter to the school. Observe that the resultant vector AD equal to AM plus MD is equal to M minus E. Obeys the triangle law. State the resultant vectors that obey the triangle law, parallelogram law, and also polygons law. Now let's have a look of Madam Tan's journey to kindergarten. So from kindergarten, Madam Tan traveled to her daughter's school. So it's actually obey the triangle law because it's vector M plus a negative vector E. So it will become M minus E. And this one is equivalent to the vector A to D. So we can say that vector C is equal to M plus a negative vector E, which is M minus E, or we can say that vector AD is equal to vector AM plus a vector MD. MD is equivalent to negative E. So it's obey the triangle law. Now we need to state the other resultant vectors by using triangle law. Example, from A go to grandmother's house, AC, it can be written as triangle law. AC is equal to AD plus with the DC. This one is obey the triangle law because it's starting from A and ending at the point C. So AC is equal to A to D plus D to C, and the point D is the interchange. Or we can say that is equal to AB plus B to C. Alright, so let's see parallelograms law. So from A to C is actually equal to A to D plus A to B. So this is a parallelogram. So let's label the parallelograms law. From A travel to C, Madam Tan go to grandmother's house. It can be expressed as A go to B plus A go to the D. So we can say that vector AC is equal to vector AB plus vector AD. It actually obeys the parallelograms law. So in short, parallelograms law consists of two triangles. So we are applying the triangle law twice to represent the parallelograms law. So AC is equal to AB plus AD. Obey the parallelograms law. Remember that AC is equal to AB plus with the AD. For polygons law, from A travel to D, and D travel to M, and from M travel to C. Make sure to draw the arrow, the grandmother's house, and from C go to the market. And it is the same with AB. This is called polygons law. That means for polygons law, AB is the resultant vector. If Madam Tan travel from A to D and from D to M, and then from the M travel to C, and from the C travel to the market at B. So conclusion is resultant vector is AB by using polygons law, right? So now we actually want to explore more polygons law. For example, we can start from point A, travel to B to the market. From the market, travel to grandmother's house at the point C, and from the grandmother's house go to the kindergarten, and from the kindergarten go to the school, and finally from the school go to the grocery shop. Vector is from A directly to X, AX. So we have managed to solve the application of triangle law, parallelogram law, and polygons law. Now for question number 3, we need to write the resultant vector for all the vectors in the table. Now let's have a look how to solve this. For the first one, we are having M plus with a negative E. So the resultant vector is AD. So we will write the resultant vector AD in the table. That is how you solve. You have to sketch out the triangle or parallelogram or maybe Polygon's law to show how you get the resultant vector. In fact, M plus a negative E, alright, so we call M minus E is equal to vector AD. Now let's see for B is M plus half of the B. This is a vector B, but we just want half of it, half of the vector B. So half of the vector B will be, we will figure out half of the vector B by finding the magnitude. So B over 2 is at the middle of the midpoint of the vector B. Alright, let's draw out properly. The half of the B, we counting the box, is actually 4 downward and then 1.5 to the left, right? So that is half of the B. So if we are going to find M minus B over 2, that means I'm going to revert the sign for the B over 2. So the negative B over 2 is the one that I label in red color. So I'm going to copy the blue vector and then write as negative B over 2 at the end of the vector M. So then I can form a triangle law, which is M plus negative B over 2. So I will get the vector which is actually equivalent to half of the AD. So I say is 1 over 2 AD. So let's write down 1 over 2 AD or AD over 2 for the vector M minus B over 2. Now we are going to solve the B minus C. Now let's see how to do B minus C. So B minus C is, we are drawing the vector B, this is a vector B, plus a negative vector C. So where is a negative vector C? This is positive C. So we want the negative C. So what we can do is, we try to find the B at the D to C, because D to C is equal vector with A to B. So we can say that B minus C is equal to from the D to B. So the answer is from D to B, right? So make sure you use a triangle law when you find the resultant vector. So for the next one, for the B over 2, we can say that is AB over 2 is the same with the half of the vector AB. So then we can also express our answer in half of the B is actually dx, is equal vector to dx. Now vector AD plus a vector dm and then plus a vector MC. Now the resultant vector for the vector AD plus dm is equal to M, right? Meaning that from A go to D and then D go to M plus M is actually is equal to M plus M, which is 2M. So the resultant vector for C plus E plus the M is equal to M plus M, which is equivalent to 2M. C plus E is M plus another M, so it will be M plus M. So the answer is equal to 2M. right? That's equal to 2m, the line missing. Okay, now for vector A to C is vector 2m, so we can write the resultant vector for this one is AC, because AC is equivalent to 2m. Right, let's discuss F. C minus half of the B. C minus half of the B. So let's figure out where is the C. C is from A to D, right? Alright, C is from A to D. And then we have to add another vector, which is negative B over 2, negative half of the B. This is half of the B. So if this is positive half of the B, how to make it negative? We will change the arrow. So let's revert the direction of the vector for the vector B over 2, so that it becomes negative B over 2. So when we plus a negative vector, it becomes minus. Now let's have a look of another question on resultant vectors. Next, let's say A to D is vector C, and then this is vector negative B. So if we want to find the resultant vector, we can cut the AD and we paste at the BC. Then we can form the triangle law. So we say the C minus B is actually from B to D, but because of the half we divide, so it becomes BM, right? Okay, let's proceed to the next one. For this vector C minus 2m, the resultant vector is BA. Okay, so the resultant vector is BA. Now let's see, this is a vector B, and we plus this vector is equal vector to the vector AD, so it's called vector C, right? Equal vector or same vector. So we have B plus C, and in fact B plus C is equivalent to 2m, right? If we plus a negative half of the B, we'll get AX, but in fact we can say we can just use a B minus half of the B, so it's half of the B, right? That's another way of doing. Half of the B and then plus the C. So we simplify first, also can. So the resultant vector is still the same, AX. So vector AX is the resultant vector, right? So next we will do B minus 2m. Let's see how to do B minus 2m. This is vector B, right? This is also vector B, same vector, minus 2m. I will use the other vector so that I can use a minus 2m. So I can plus because the arrow are heading the same direction. DA is the resultant vector. So let's fill up the space with the resultant vector AX and the resultant vector DA, and let's proceed to M, vector M minus C minus B. This is vector M, and then we are going to plus with the vector, right? So I will prefer this one, M, and then I will continue with the minus C and then plus a B. So this is M minus C. Can you see the arrow is opposite with the C? Right, so it's M minus C plus B, and the resultant vector is M heading to A. The resultant vector for M minus C minus B is MA. What about B minus C over 2? Since we have C minus B over 2 is BM, Hence, if we factorize the negative, it's negative c minus b over 2, so it's negative bm. So we can write as vector mb, right? So that's all my sharing about Madam Tan's daily life story. Till then, bye bye and have a nice day.